Welcome back, everybody, to exciting video physics land. Today we're going to do motion graphs number 3. Now, I think we're getting pretty close to the end of these motion graphs, so hang on tight. We're almost there. You're doing good. Today, we're going to only try to get through one thing, and that's changing a velocity versus time graph to an acceleration versus time graph. Now, I haven't even mentioned acceleration yet, so first we'll define that and then we'll see what we can do. All right? So let's look back at what we did just last time. We made a just big, ugly, nasty graph here. We wrote all over it. We started with a position versus time graph. We found the slopes on it. Then we used those red dotted lines and projected straight down onto a velocity versus time graph. And we put those velocities on there. Now here's what I want you to remember. The slope of the position graph was the velocity. And I'm going to write that up here and we're going to come back to it. Remember this. Velocity was the change in position over the change in time. That was slope. That was rise over run, just like you did in math. That from the upper graph, let us make the lower graph. Okay? Now notice something here on our velocity graph. All the velocities are flat lines. They're constant. So look at that first section, the first 4 seconds. The velocity is constant at 2 meters per second. The next 2 seconds, it's 0. And then for the last 4 seconds, it's 0.6. Okay? It does change, but the point is those lines are flat. So the question is this: what would happen if we let the velocity change? Kind of like this. So now the velocity isn't flat anymore. I kept the same axes. All I did was erase the graph and put in a new one. So check out what's going on. At 0 seconds, the velocity is 0, and it slowly gets bigger and bigger and bigger. So the velocity is increasing. It's speeding up, whatever this is. Maybe this is a car, or perhaps a bicycle, or maybe a ball rolling down a hill. It's going faster and faster and faster and faster and faster all the time. It's speeding up. All right? So the question is, what do we call that? When something speeds up, or for that matter, when it slows down, when the velocity changes. Okay, see if you can guess. I think you probably got it. We call it acceleration. You know that. When our car accelerates, it's speeding up. When it decelerates, it's slowing down. Now, for our physics class, we're going to call both of those accelerations, and we'll talk some more about that in a little bit. But here's the point. When something changes velocity, there's an acceleration that happens. Now, here's the fun. The acceleration is how the velocity changes with time. It's the change in velocity over the change in time. Now, I'm going to jump back to that last slide real quick. Notice the big red circle. The velocity is delta x over delta t, change in position over change in time. The acceleration is the change in velocity over the change in time. And the last thing to remember, that's the slope. So the slope of the velocity versus time graph is the acceleration. Okay, we're doing just exactly the same thing we did in the last video lecture. So, before we move on, I'm going to take a quick second and cover one thing. We got to talk about the units on acceleration. So let's see what we have. Acceleration equals change in velocity over change in time. Change in velocity. Velocity is meters per second. Time is in seconds. So listen to these units. Meters per second per second. Meters per second per second. That's really weird. That's super strange. Now I'm going to do a little math here for you. You'll need to trust me just a little bit, but I'm going to rewrite this as meters per second. I just rewrote the numerator. We okay with that? And instead of dividing by seconds, I'm going to multiply by 1 over seconds. Okay? You may not have seen this done in math before. This is kind of like pirate math, like swashbuckling math a little bit. Arr, matey, we're going to play with units. So now I'm going to multiply across the top and across the bottom, and I get meters per second. Second times seconds is seconds squared. So there's two ways you can write meters per second per second. Either one of those is fine. It doesn't matter. We're gonna work with these a bit. So this probably feels totally uncomfortable, but don't stress yet. All right? It'll start to feel good in just a little bit. The units on acceleration are meters per second, or you could also say meters per second squared. Okay? Moving on. Here we go. This is what we're here for today. Notice what I did. I made a velocity versus time graph. Now, I'm not going to go through all the math because we already did that. I'm going to assume we can do this. And we're going to calculate the slope for that part of the curve. And the slope is going to be 2. I'm just totally making up that number. Notice I didn't put numbers on the axes. I didn't label it. I didn't put the little hash marks, the whole 9 yards. We did that before. And I'm going to jump back to the other graph. Okay? Something like that. Notice the shape is the same, but that's a position graph, that top one there. Okay? So jumping back down now, we're going to say the slope is 2. I want you to see if you can write down the slope of the line right here. What's the slope? Hope you got 0. It's flat. There's no slope. And then this one, I'm going to make up a number. Let's make an easy one. The slope is going to equal 1. All right? Now I'm just doing this so we can go a little fast. I think you guys can draw axes and you can put all the labels on and everything. We're just going to try and speed this up a touch. So here we go. Next step is we project down wherever the graph changes. Straight down onto the graph below. This is just the same thing we did with the position to velocity. Now we're doing velocity to acceleration. All right, let's look at section number 1, just the first section where the slope is 2. All right, in that entire section, the slope of the line is 2, which means I'm going to pick 2. I'm just going to put it on the graph. There's 2. And it's constant. The slope is the same the entire time. What's the slope in the middle section? Drops to 0. Boop. There it is, down at 0. And then how about for the last section? See if you can do it. Skip ahead. Do it before I do. I'll give you a hint. There's 1. How'd you do? Did you get it? So check it out, folks. We just went from a velocity versus time to an acceleration versus time. I went a little fast because we did this before. It's the same process as going from position to velocity. All right? How'd we do? Hope you feel okay. Here's your video lecture problem. Go ahead and pause me whenever you think you need to, and enjoy yourself. See you next time.